Okay, so welcome everybody to the GSE Virtual Conference 2023. So this is the first session on the IMS stream, and just practicalities through the meeting. Subhadash has said that he does not mind anybody actually verbally asking any questions in the meeting, so that's good. So if you want to do that, then you're more than welcome. But if you raise your hand, then what I'll do is I'll unmute you, because everybody is actually on mute apart from the speaker at the moment. But just bear that in mind, that you have to unmute yourself, and I think I'll just have to disable the all mute before you ask that question. So you're more than welcome to ask questions. So the title of this session is how the CM1 SL0 input message sent to IMS Connect works. So these sessions that Subhadash is doing for us, he's doing 3. This is one of 3 sessions, and it's in depth about the messaging. He'll talk about both the cases where the sync point completes successfully and the sync point failure occurs. So Subhadash has been he's a BMC Army data for IMS portfolio and product solutions, so that's where his forte is at the moment. He's been about 7 years with BMC so far, and he's worked with the IT industry over 15 years. Had extensive knowledge of IBM Z mainframes. So without further ado, I'll pass over to Subhadash.
Hey, thanks, Dom. Thanks for a nice introduction, and welcome everybody to the session. Thank you for taking the time to listen to me. Yeah, I think it would be an interesting session, and hope I'll be able to deliver something meaningful, which obviously all the audience can take away. Yeah, so as Dom said, I'm a product manager or a product owner, whatever you call that, for the BMC AMI data for IMS portfolio of products or solutions for and work for BMC Software. I have been with them for 7 years. I started working in BMC Software as a systems programmer. I have enjoyed roles of being a QA engineer, automation platform engineer, security analyst. Well, let's not call it analyst, security, technical support specialist. And then finally, I got an opportunity to move into the role of a product manager. And great for me, I got the opportunity to work with the IMS products first, because IMS has been a true love in terms of technology for me. I had been an IMS application programmer way back in the days when I started my career in IT. So it's good to be back in IMS again. Yeah, so enough about me then, and let's get into the technical topic now. So the subject matter of today's discussion is how CM1 SL0 input message sent to IMS Connect works. And I'm obviously not going to go into huge depth of what commit mode and synchronization level are. That's not actually the intention of today's session, but I definitely, as a starting point, I definitely introduce some of these terms, and then we will get into how a CM1 SL0 input message actually works when the message gets sent to IMS Connect from an IMS Connect client. So before going into the technical details of the session, just a brief introduction about what the session is all about. So in this session, I'll talk about what happens when an IMS Connect client sends a CM1 SL0 input message to IMS Connect. And I will talk about, as Dom alluded to, I will talk about both the cases. Number one, when the sync point completes successfully, and the second case is the case of a sync point failure occurring. Right. So let's talk about the first case. what happens when a CM1 SL0 input message sent to IMS Connect works. So that's the generic topic that we will start about. And then as we go through the steps, I will delineate between the steps which happens when the sync point completes successfully and those which occurs when the sync point failure happens. So as just to introduce the topic, the IMS Open Transaction Manager Access or OTMA client communicates information to IMS as well as receives information from IMS in a prefix which is passed in front of the message, or for that matter, IMS command, right? So there are several detailed level of information that are present in the prefix, but the two which are of importance to us with regards to this session are something which we call the commit mode and the synchronization or the sync level, right? So and we have two commit modes, which are commit mode 0 and commit mode 1. I'm not going to talk about commit mode 0 in this session because we are not dealing with commit mode 0 messages over here. I'm going to talk about commit mode 0 messages in later sessions. I think there is one more today after 1 hour, and there is another day after tomorrow. But today we are going to specifically focus on CM1, which refers to commit mode 1, which is actually the send then commit mode. So it's very simple. You send the message and then you commit the message, right? So IMS doesn't actually wait for the commit process to complete before sending the message. It sends out the message first, and then the commit processing happens. Or in IMS words, the sync point processing happens later. And SL0 is sync level 0, which in simple terms, which means that the output message sent by IMS is not acknowledged by the OTMA client. So IMS processes the transaction, the input transaction, it generates an output message, it sends out the output message back to the OTMA client, but the OTMA client does not need to send IMS any acknowledgement, whether it's a positive acknowledgement or negative acknowledgement, it doesn't matter. The OTMA client doesn't send any acknowledgement back to IMS for SL0 input message. Now, IMS Connect, I mean, we all know about what IMS Connect does, but just for the sake of the completeness of the introduction, I'll just introduce what IMS Connect is. So IMS Connect is an IBM provided OTMA client for TCP/IP. So in very simple words, it's IMS's TCP/IP gateway, right? So we will refer to the we will talk in this session about in detail about what exactly happens when an IMS Connect client sends a CM1 SL0 input message to IMS Connect. And IMS Connect I'll interchangeably use the terms IMS Connect and Icon. So I think IMS Connect is lovingly also called Icon in short. So I'll be interchangeably using the terms. So let's get into the details. So when an IMS Connect client, the first step is an IMS Connect client sends a CM1 SL0 input message to IMS Connect. So that's where the process starts, right? And then what IMS Connect will allocate a control block, which is called the SVT control block for the client, if the control block does not already exist. And then IMS Connect will send the input message to IMS OTMA via XCF, the cross-coupling facility. The transaction pipe or the T-pipe name would be the port number that receives the input message. And then OTMA, after it receives the the input message, the CM1 SL0 input message from IMS Connect, it obviously goes on and proceeds with the processing of the input message. A OTMA will now create another control block, which is called a TIB, or a transaction instance block, right? It's allocated by OTMA. There are some other things that also happens, depending on the level of security that uh, uh, that you have configured the IMS Connect to work with. So for example, RACF or any other system authorization facility or SAF product is called if needed, as I said, depending upon the level of security that is set up. And the input message, and this is very standard stuff. So the input message is first inserted into the IMS message queue, and then finally enqueued on the transaction queue, right? So now next what happens is the application program, the IMS application program actually comes into picture. So the IMS application program, it will do a get unique or a GU to the IOPCB, the input output program communications block, in order to retrieve the input message. And then the input message will be processed by the application program as per the existing logic that has been coded in the application program to handle the transaction. And then after the application program is done processing the input message, it will do an insert or ISRT of the reply message to the IOPCB. The reply message is then anchored on the TIB. So remember, we talked about just a few minutes before, we talked about OTMA. When it receives the input message, it starts processing the input message, and as a first step of processing, it creates the TIB or the transaction instance block. That's a control block which is created by OTMA. Now the reply message is actually anchored on this TIB control block. And IMS OTMA will now retrieve the reply message from the message queue, right? So after the application program was done processing the input message, it did an ISRT or insert of the reply message to the IOPCB. Now IMS OTMA will actually retrieve the reply message from the message queue. Now, after it does that, IMS OTMA, obviously it sends the reply message to IMS Connect, again through XCF, cross-coupling facility, cross-system coupling facility, and deletes it from the IMS message queue, right? So OTMA grabs the reply message from the IMS message queue, it sends the reply message to IMS Connect through XCF, and then deletes the reply message from the IMS message queue. Now something interesting happens. IMS Connect, what it does is, after it receives the reply message from OTMA, it has to anchor the reply message on the SVT. I'm sure you must be remembering that, IMS Connect had allocated a control block for the client, which is called the SVT control block, when it received the CM1 SL0 input message from the IMS Connect client. So now IMS Connect anchors that reply message on the SVT control block, and it waits for something which is called the deallocate or the deallocation message from OTMA. Now, we have to remember that for CM1 SL0, even though the OTMA client, in our case, which is IMS Connect, receives the message before the sync point is complete, it should not process the message until it receives something which is called a deallocation message. In our case, which will be deallocate confirm message from OTMA. If the sync point completes successfully, it will be a deallocate confirm message. And if the sync point, if there is a failure of the sync point, then it will be a deallocate abort message. But nonetheless, it's a deallocation message, right? And this deallocation message indicates the status of the sync point. Depending on whether the sync point is successful or it's a failure, it will be a deallocate confirm message or a deallocate abort message.
Suradash, is
Yeah.
it all right just to pull the slide up a little bit, because I think we're on the last third there. Yeah.
Sure.
Right.
Yeah, absolutely.
Brilliant. Excellent.
Yeah.
Thank you.
Thank you. Yeah. Thanks for reminding that. Okay, great. So now what happens is now the game of sync point processing begins, right? Now it's all about this game, how the sync point processing happens. Now the sync point processing will start. OTMA will start processing the sync point, and I guess in terms of IMS language, if you may call it IMS language, this sync point which OTMS starts processing is what is termed as the phase one sync point. You know, you actually do not need to differentiate between the phases of the sync point, but if you really get into the technical nitty-gritties of this sync point processing, when OTMS starts processing the sync point, it's what we call something as a phase one sync point, and this phase one sync point begins. Now, from step number one till this step, whatever I have talked about, these steps are uniform for the overall process. What I mean by overall process is the IMS Connect client sending a CM1 SL0 input message to IMS Connect. So if we just consider this part, so whatever I have talked about till now, all these points apply to this part, what I have highlighted on the screen right now. But then, as we know, there are two interesting ball games that are supposed to be happening afterwards. Number one, we do not know yet whether the sync point is going to complete successfully, or number two, whether there is going to be a sync point failure. Now, these are the two branches of the tree, if you may call it, depending on which the steps which I'm going to talk about now are going to vary, right? So let's first consider the branch of the sync point completing successfully. So in that case, obviously, the sync point processing will complete successfully, and with that, the phase one sync point will end, right? So the phase one sync point processing completes successfully. Then what happens is OTMA sends that deallocate confirm message. Remember the deallocation message, if it's a sync point success, so the deallocation message will actually be a deallocate confirm message. Now OTMA grabs the deallocate confirm message and sends it to IMS Connect. But there is a caveat over here. I mean, this doesn't happen if it's a conversational processing. So a conversational processing is a different beast and a different ball game altogether. I'm not going to enter into the conversational processing, but let's remember that OTMA sends the deallocate confirm message to IMS Connect. The exception being conversational processing or conversational processing, message processing does not apply to this particular case. Now, OTMA deletes the TIB control block and frees the input message. Remember, the message had initially been anchored on the TIB control block by OTMA, and now OTMA, after sending the deallocate confirm message to IMS Connect, it can safely go ahead and delete the TIB control block, because remember, the sync point has, the phase one sync point has ended successfully, and OTMA has been successfully able to send the deallocate confirm message to IMS Connect. So it does no longer need to hold the TIB control block. So it can go ahead and safely delete the TIB control block, and it can go ahead and free the input message. Now, what actually happens is OTMA actually goes ahead and frees the DRRN, which is the disk relative record number of the message. And DRRN is the actual address of the message within the IMS message queue, right? So that's basically freed up, and that's what we are calling deleting the TIB control block and freeing the input message. Now the sync point, the phase two sync point also ends. So this is basically the phase two sync point is basically the IMS application program sync point. So as a starting point, the phase 1 sync point, which was the OTMA sync point started by OTMA, IMS OTMA, that ended successfully. And then after the deletion of the TIB control block and freeing of the DRRN of the input message, the IMS application program sync point, technically referred to as phase 2 sync point, that also completes successfully, right? So now the sync point processing is actually complete. It's a successful sync point processing. So what happens is IMS Connect will now send the reply message to the IMS Connect client. It can safely do that now that the sync point has completed successfully. Now, if a persistent socket is in use, IMS Connect actually keeps the connection open and does not free the SVT control block. Or otherwise, if a persistent socket is not used, the SVT control block is also freed, right? And finally, the IMS Connect client processes the reply message. Now, this is what happens or goes behind the scenes for sync point completing successfully. Now we take the route of the second branch of the tree, which is a failure of the sync point happens, right? So the phase 1 sync point, which we previously termed as OTMA, the sync point started by OTMA, the phase 1 sync point processing will fail. OTMA will process the sync point failure, and then it sends two messages. It sends a DFS XXX message over here. Let me go to this slide. So the different entities involved in the sync point failure case is exactly the same as in the sync point successful case. The differences are, in this case, OTMA, after the phase 1 sync point fails and OTMA processes the sync point failure, it sends a DFS XXX message and a deallocate abort message. So the previous case was a deallocate confirm message. In case of sync point failure, it will be a deallocate abort message plus a DFS XXX message, right? So this DFS XXX and deallocate abort messages are sent to IMS Connect by OTMA through the XCF, the cross system coupling facility. And remember that the messages can arrive in IMS Connect through XCF in any order. OTMA will delete the TIB control block, and the phase 2 sync point will fail. In other words, the IMS application program sync point will fail and the application program will abandon. Now what happens is IMS Connect will process the sync point failure and it will discard the reply message. Remember, in this case, IMS Connect doesn't need to send the reply message back to IMS Connect client. It can simply go ahead and discard the reply message because there has been a sync point failure. So IMS Connect will process the sync point failure and it will discard the reply message. IMS Connect will also send the DFS XXX message to the IMS Connect client. Now, this is the DFS XXX message is the message that the IMS Connect client will eventually process. So, and again, if there is a persistent socket in use, IMS Connect will keep the connection open and does not free the SVT control block. Otherwise, the SVT control block is freed. And finally, the IMS Connect client will process the DFS XXX message, right? Saying that, I don't remember the exact message on top of my head. I guess it's a DFS 351I message, if I remember, if I remember that correctly. And it will simply say that transaction so and so abandoned with user aband 351. No, so it denotes that there was or were some problem or problems in this whole process, and the ultimate summary is the sync point couldn't complete successfully, and so the IMS Connect client, instead of getting the actual reply of the transaction from IMS, it gets this DFS, I guess 351 I message, indicating that there has been a sync point failure somewhere down the road. Okay, so now let's do a practical study. Yeah, please. Go ahead, please.
Sorry. If anybody does want to ask a question, then please do. Or we can put it in the chat, either. No? Okay. I think you can carry on with some of that.
Like to, please feel free to stop me at any point in time. That's not a problem. So let's proceed with let's take a look at a practical study of how this entire theory works, right? It behaves in the background. So here, BMC AMI Energizer for IMS Connect product has been used to demonstrate the behavior of CM1 SL0. Now, let me be very clear. This is by no means a sales pitch for any BMC product. I do not intend to do that at all. I have simply used the BMC AMI Energizer for IMS Connect product here because that is what is readily available to me to use for free. Remember, I'm the product manager or the product owner looking after BMC AMI Energizer for IMS Connect. So it's a free to use tool for me and to experiment with. So that's why I have taken some of the screenshots in order to show how practically the CM1 SL0 flow happens in the background, right? So as you can probably understand by looking at these two images on this slide, I have executed the famous part transaction, the AN96OC10, the famous part transaction. So please take note of some of the noteworthy options here. So for example, if you take a look at the first image, I have selected the protocol as CM1 send commit. So this is the commit mode, right? So this is the CM1 commit mode. Also, if you take a look over here, I haven't selected any confirmation options. So I have neither selected the confirm or ACK option, nor have I selected the reject or NACK option, which denotes that the synchronization level or the sync level is set to SL0, right? So with that, let's take a look at, let's break the transaction execution output down into parts. And remember, CM1 SL0 is probably by far, I can say that it's a very straightforward protocol in terms of OTMA message processing, right? When SL0 becomes SL1, a bit more complexity is introduced into the process, because then the IMS Connect client has to either send a positive acknowledgement, which is an ACK message, or a negative acknowledgement, which is a NACK message. And I think that is my next session, which is probably 1 hour from now. But CM1 SL0 is a relatively straightforward message processing protocol in OTMA. But nevertheless, let's break down the transaction execution output into parts. So in the first part, as you can see, the transaction part AN96OC10 is sent to IMS. So I'm sending the message to IMS, right? And this is the actual message that has been sent. So over here, if you see, this is the message. This is the transaction message that has been sent to IMS. And in the second part, if you see over here, just let me go down a bit. In the second part, if you see, you'll see that IMS has sent the reply back to the client, right? And if you just go through some of these pieces of the reply, so this is the response that was received. So this is the output of the part transaction. It's a washer part and things like that. This is the response time. And then you see over here something called a CSM segment. So CSM, okay, it states over here. So CSM stands for complete status message. So in short, any successfully processed output message from the IMS Connect message exit sent to a client contains this segment, which is called the complete status message or the CSM segment. Now over here, if you go down this highlighted piece over here at the bottom, it says CSM OKY. So this CSM OKY actually means CSM OK. So which in turn effectively means that the output reply message that was sent by IMS to IMS Connect has been successfully processed through the IMS Connect message exit and sent back to the IMS Connect client, right? So this in effect tells the user that the transaction that was sent to IMS by the IMS Connect client, and it was a CM1 SL0 transaction, as you can see over here, CM1, and then neither ACK nor NAC has been selected. So it was a CM1 SL0 input message that was sent by IMS Connect client to IMS, has been successfully processed by IMS, and IMS has sent the reply back to the IMS Connect client, which is, and this is the reply of this is the transaction output basically. And the CSM segment message says it's the CSM message segment is okay, which means that the output reply message that was sent by IMS to IMS Connect has been successfully processed through the IMS Connect message exit, and it has been successly sent to the client.
So that's going to just to get
Sure.
that clear. So it's definitely, so that is the line 120 there is the CSM OKY. That is the actual thing to check, is it, to look at to see whether it's okay?
It's right.
Yeah. Okay.
Right. And then obviously, if you see over here, this socket has been closed also with a return code 0.
Okay, got it.
Yeah, right. And I think the my next session will be a bit more interesting. As I said, you know, if you are a fan of theory, you know, all this sounds really interesting. You know, all these things happening in the background. But if you actually take the help of a tool, be it a BMC tool or a Broadcom tool or an IBM tool, and then if you take a look at a CM1 SL0 output, it's a very straightforward output, right? I mean, because the client does not need to send any acknowledgement back to IMS. So it just sends the transaction input message to IMS. IMS processes it with all these complexities in the background, which as an end user, you do not worry about or you do not need to bother. IMS takes care of all that complexity. And then it basically, if the sync point processing completes successfully in the end, you just get the reply back, right? And so in terms of, from the perspective of an end user, the CM1 SL0 protocol is actually a very straightforward protocol. But my next session probably wherein I talk about CM1 SL1 protocol, things will get a little bit more complex, because then the then the picture of the IMS Connect client having to send an acknowledgement message, either in the form of a positive acknowledgement or a negative acknowledgement, comes into picture. And then if I execute the same transaction, and in that session, I have actually captured the same screenshot running the same transaction for CM1 SL1, then that same transaction will no longer be broken down into 2 parts. It will actually be broken down into 4 different parts. So a little bit more complexity will be involved in that process. But from an end user, CM1 SL0, oh yeah, it's very simple. You send the input message to IMS processes it, the sync point completes successfully, hoping that the sync point completes successfully, and then you just get the reply back, and you don't care about anything else, right? So yeah, I think that's what is all about the CM1 SL0 input message processing, the theoretical part, and from an end user perspective, the practical application of it, right? So it's comparatively simple, as I said. So I think that's all I had to share for this particular session. And Tom, would you like to talk a little bit more about this session feedback?
Yeah, sure. So, I mean, I was going to ask a few questions first, but definitely go for feedback, everybody. Thanks for being here, and there's about 8 of you in here, which is great. So I've just tried to say to unmute all. So if anybody wants to ask questions, then please do now. I mean, I've got a few, but please put your feedback for this session. You just go online, as it says, and the session code is 5A. And Subhash is going to be doing as you said, the more complex one coming up at 10:30 UK time. So got a little break, and then we'll continue with the CM1 SL1 messages and how they get treated. Now, so yeah, thanks for that. And there's a QR code there on the screen. Hopefully you could pick up on that. I've got a little question. I think you were mentioning it before about the tools that you can use to actually get the IMS Connect message. So is that a started? I'm being really ignorant here and saying, is that so? You've got the IMS messages that come in. They go to the IMS log, and then there'll be some information regarding the Connect part of it. And that then goes back to the IMS Connect. And where can you actually put that utility to actually see the message that you were displaying on the screen just before? So you did mention that you've got particular software. Yeah. So I think you got to unmute yourself there. Yeah, that's it.
Okay, great. Yeah. So yeah, Tom, a good question. But this question is, if I'm to answer this question, the answer is going to be specific, different for different tools. So since your question is specific to this particular screenshot and in this particular process or this particular tool that I have used, so this is a BMC tool. So BMC AMI Energizer for IMS Connect tool. So how it works is, it basically, BMC AMI Energizer for IMS Connect works within the address space of IMS Connect. So you have to have, if you do not have this tool, let's say you do not have this BMC tool, but you have IMS Connect set up in your environment. So you have got a separate address space that is running in order to support IMS Connect, right? Now, if you have this tool, which I was talking about, Energizer for IMS Connect, it's basically a tool that integrates into your IMS Connect address space. So you have to make a few changes to the IMS Connect address space. You include the load modules for this particular tool, and you recycle your IMS Connect, and that's it. You are up and running. So and now this particular functionality, this particular ISPF screens, which I'm showing over here, So if you just take a careful look at it, if I may enhance these images a bit. So if you see over here, this is a verify IMS connectivity panel. So this is a feature in this tool by which if you can take a look at all these options over here. So this is basically a test set of functionality that has been provided with Energizer for IMS Connect. So if you want to verify that any of these protocols are working correctly as they should in your working environment, this is the panel which you can go to. You can just select the specified options over here, hit enter, and in the background, Energizer for IMS Connect will behave as if it's a client to IMS Connect, and it will send the message as if an IMS Connect client is sending that particular message to IMS, right? So it basically simulates the behavior of an IMS Connect client. So if I'm to say it in very simple words, I'm not sure.
Yes, great. That did answer the question.
Great.
That's perfect from my perspective. Has anybody else got any more questions verbally? Because I'm conscious I've unmuted everybody, though. I think you still have to unmute yourself if you want to ask a question. So have we got any more questions for Subhadash on this particular stream session? As I said, we have got the next one coming up about the SM1 SL1 messages, which is a bit more complicated. So that one's coming up at about 10:30 UK time. But any more questions, then please feel free to shout now. And I think, as I said, you do need to unmute yourself. I mean, I can ask to unmute anybody actually by just clicking these, but you might not have any questions, so that's fine. Okay, so thank you very much indeed, Subhadash, for that session. It's definitely interesting and a good detail on that. And as we said, we've got feedback on this session, then please submit it online, and you got the QR code there to do that. And we look forward. There's another 7 sessions of IMS, so there's various different things. We've got a couple more from Subhadash on IMS Connect, and which one of those which is coming up, and then further one on Thursday, I think. And we've got some other sessions as well. So we look forward to seeing some of you at those sessions. And thanks everybody for your participation. Thanks Subhadash for this session. And I hope you have a good rest of the day and a good conference. Thanks everybody.
Thanks a lot, everybody.
Thank you. Bye.
Yeah. Bye for now.
Subhadash.
Yeah. Thank you.
All right.